Welcome back, Stella. I hope you're doing well. I forgot to tell you something last time, and I thought it was very important for me to remind it. Okay, I said last time a definite integral. Let me go back to the slide. I said last time a definite integral, this is the definition, will always depend on what? On the starting variable, since no boundaries are being given. You understand? Why? On the other hand, a definite integral doesn't depend on what? On the starting variable. Look at this. The integral from a to b of f of x dx is simply equals to what? F of b, capital F of b. So you first find a primitive. Then you apply the boundaries, which is capital F of b minus capital F of a. Notice that this is a real number. This is a real number. This is also what? A real number. So the result will be what? A real number. So what we can basically conclude here is that a definite integral does not depend on what? The starting variable. It is independent of the starting variables. You understand? And a definite integral will be independent of the starting variable. So that's an important point I wanted you to note. Okay, in this video, we shall basically look at some properties. We shall basically look at 1.3. So we saw this already, the difference between definite and indefinite integrals. Today we shall look at some basic rules or some basic algebra rules in integration. So let me go to the slide. Some basic algebraic rules in integration. Okay, there are certain important rules you need to know for you to basically be at ease when working in integration. The first rule states that if f of x equals to 0, then the integral of f of x dx will be equals to what? Let me give you some time to reason. If a function is equals to 0, what must be its integral? Its integral must be what? What is the function that if we derive, we obtain 0? That's the same question. That function is simply what? A constant k, where k belongs to what? K belongs to the set of real numbers different from 0. You understand? So the next rule states that if f of x is equals to a, where a belongs to the set of real numbers different from 0, then the integral of f of x dx will be equals to what? What is the your variable? The variable is x, so the integral will be equals to ax plus the constant k, where k, let me say k1, where k1 belongs to the set of real number. This can be integral can be proved very simply using what? Using in this formula, integral of x to the n dx, which is equals to x to the n plus 1 all over n plus 1. Here your the x that's close to the a is simply what? X to the 0. You understand? So it's very simple to prove them. So let's see the next rule. The next rule states that rule 3, the next rule states that if f of x is equals to u prime v plus u v prime, where is this formula coming from? This is simply what? This is simply the product rule. Our product rule we saw in differentiation whenever we are asked to differentiate what? Products, which is the formula is v du dx plus what? This u prime is du dx. V du dx plus what? u dv dx. So if f of x, if you notice that f of x is simply a function that resulted from differentiating a product of two functions, that is, which is in the form this, then the integral of f of x dx will be equals to simply what? U times v. You understand? So let me take a small example. Let's say, for example, you are asked to integrate. Let's say, for example, you are asked to integrate. Let's say, let me take a small, very simple example. You are asked to integrate. Let's say sine x plus x. Let's say cos x. Sine x. Let me see. Let's sine x plus x cos x. Okay, this is a very simple example. Let's ask you are asked to integrate this. You notice that your u here is what? Your u here is x, and your v is what? Your v is simply cos sine x. You see that this u prime is what? This one. This v is what? Sine x. So here, what was being differentiated? X was being differentiated here. And what was being differentiated here? Sine x was being differentiated here. So the integral of this is simply what? The primitive, if I would say the primitive, yes. The primitive of this will simply be equals to what? X sine x plus what? The constant of integration k. I don't know if you are trying to see how we can apply this, how I'm applying this. So that's basically how you can apply that. So let's see the next rule. The next rule, the next rule, rule 4, which states that if f of x is equals to what? U prime v minus u v prime all over v squared, then the integral of f of x dx will be equals to what? If you have something of this form, what does this formula reminds you? This is simply the quotient rule in differentiation. Whenever you wanted to differentiate, whenever you are asked to differentiate a quotient, this is the formula you use, which is simply v du dx minus what? U dv dx all over v squared. That's it now. So the integral of this will simply be equals to what? Uv. There's a constant of integration here plus k. U on v plus the constant of integration what? K. You understand? So let's look at the next rule, rule 5. Let's look at the next rule. Let me go on the next slide. Rule 5. Rule 5 simply states that the integral of f of x on g of x dx is never equals to the integral of f of x dx all over the integral of g of x dx. Never you do this error. So never try to write this in this form. It's not the same thing. Rule 6 states that the integral of f of x times g of x dx will never be equals to the integral of f of x dx times the integral of g of x dx. This is not the same thing. So be very careful. Don't do such errors. The last rule which states that recall, in fact, this is something I want you to keep very kindly. In fact, keep that very in a very strict way in your mind. This will be a very important rule we shall use in certain integrations. Let me recall something first of all. Je pense que tu te rappelles que si on te dit de differentiate, si on te donne un function f of x, if you are given a function f of x and you are asked to find the derivative of f of x, je pense que tu te rappelles que the derivative of f of x with respect to x can still be noted as what? F prime of x. Recall that. This simply means that the d of f of x is also equals to what? If I make d of f of x the subject here, so it is here, d of f of x, there are brackets here. If I make d of f of x the subject, it will simply be equals to what? F prime of f of x times what? Dx. This is a very important formula. Take note of this. Take note of this. It will be very useful in a lot of examples we shall see in the upcoming videos. So let me try to show you how, for example, let's see a small application of this. Let's say, for example, you are asked, if I will say, let's say, for example, you are asked, it said that, let's say, let y be equals to x cubed. If you are asked to find dy dx, if you are asked to find dy dx, dy dx will simply be equals to what? 3x squared. That's it now. Another way of finding it is that I can use this formula. When I come here, this is y. I differentiate y. When I differentiate y with respect to y, what does it give? It gives 1. And after doing that, I write y times dy. I go to the next side. This is x. I differentiate it with respect to x. It gives what? 3x squared. And since I differentiated with respect to x, I write here what? Dx. You understand? So here you will be left with what? Dy being equals to what? 3x squared dx. And if I bring dx on this side, this will give dy dx equals to what? 3x squared. So we have what? The same answer. Let's take another example. Let's say you are given y squared being equals to what? 4x squared. If I'm to pass through this method to find dy dx, I'll first make y my subject. That's it. Y will be equals to what? The square root of 4x squared, which implies y will be equals to 2x. So dy dx will be simply equals to what? 2. That's it. So let's pass now through this other method. Let's pass through this method. This is y. So we have y squared equals to what? 4x squared. I'll do the same thing. This is y. On this side we have what? Y. We have y on this side. That's it. So this is y on this side. I differentiate it with respect to y. I have what? If I differentiate this with respect to y, I have 2y. Since I differentiated this with respect to y, I write y dy, which is simply equals to, I will then differentiate this other term with respect to what? The variable x, since x is the variable here. So I will have 4, I'll instead have, when I differentiate this, I will have 8x. Since I differentiated this with respect to x, I simply write what? Dx. So it implies dy dx will be equals to what? Will be equals to 8x on what? 2y. But what was y? Y was equals to y here. Y here is simply equals to what? The square root of what? 4x squared, which is equals to 2x. So I'll come and replace it here. This will be equals to 8x on what? 2 times 2x. This is 4. 4 here, 2 times, 4 here, 1 times, x goes, and we simply have dy dx, which is simply equals to what? 2. So we have the same answer as this. So this was a simple illustration. So remember this formula. In some upcoming videos, you are going to see how we basically use this in finding integrals. So that was all for this video. So try to remember all these rules. They are very important rules. Try to remember them. Remember them because they will be very useful in the upcoming videos. So they are basic rules of integration. So let's take ourselves in the next video where we shall start with indefinite integrals. We are going to start with real things now. We are going to start with indefinite integrals in the next part. So this was the end of the first part. In the next video, we shall start with indefinite integrals. See you in the next video.